This topic, like modeling with the normal distribution, is very important. And here we can see that German mathematician Carl Friedrich Gauss showed that measurement errors made in astronomical observations were well modeled by a normal distribution. This is one thing. And the Belgian statistician and sociologist Adolphe Quetelet later applied this to human characteristics. And you see, when he saw that distributions of such things like height, yeah, so like height and then weight and basically also uh, girth and strength were approximately normal. This is very interesting. And we are now like in a position to apply the knowledge that we know about normal distribution to the real life situation. And how we can solve this numerically. We need to understand the very basics. So here, just pay attention that you know some basics about normal distribution, and we are going to speak about how to apply those things. Look, let us have an example here. The mass of newborn baby is in a certain region is normally distributed with mean like this amount of kilogram and variance like that. So what we can say, if we have mean and variance, then we can make that this basically x is normally distributed, and we have mean basically is 3.35. Sorry, 3.35, and here is 3, and then variance is and variance is 0.0858. So this is like normal distribution, let me say. We just have the mass of them as certain normal, and we have to estimate how many of these amount of babies born last year had masses less than 3.5. So what we need to do, we need to basically understand that we have to find our probability, basically. We have to the mass of the estimate how many of them. So how many of this amount of babies were born. So what we need to do, we need to have we need to find the probability that the baby born is in the certain region, in a certain class. And if we know that we have 1,356 babies, and we want to have the masses less, and we know that the distribution is normal, so we can say that we can find the probability that x is smaller or than 3.5. And you can see that here we have to find that, and this is how we found it. And we need to know how to do that, but we need to standardize because we know the function phi, which can be standardized, and you can see here we can use the things for standardization. You already know how to find those functions in the table, so I will not refer to that. But you know, here you just standardize and you get basically this amount. So what does it mean? It means that you can represent it as percentage. So it's like 69, 69.57%. Here it's also written. So this is the amount of the babies which are less than 3.5. And now you just need to multiply this amount by that and you will get this. And if you have something like not integer, of course you cannot take this part because it's not, you cannot have a part of a baby. So it means like only integer parts does matter. And the answer is for 943. I hope it's understandable. And you can see the tip is that we cannot know the exact number of newborn babies from the model because it is like only gives the estimates. But however, we do know that the number of babies must be an integer. This is important. And here we can have a look so that another example, like you see a factory produces half-liter tins of oil, and the volume of oil in a tin is normally distributed with mean of these amounts of milliliters and standard deviation from that. So please understand that. So we can have this amount, and so this amount of milliliters with the mean, and standard deviation is the following. Standard deviation, please understand, this is the square root of variance. So in the previous example, it was variance given, yeah, but now we have a standard deviation. And what percentage of the tins contain less than half of a liter of oil? So it's quite easy. If you want to find that, you need to know that first you need to standardize, and if you have the amount like half of this, so what we need to do, so we need to have a percentage that contains half the liter of oil. So it means that it needs to have 500 milliliters. And 500 milliliters we need to standardize by using this mean and standard deviation. And you can see here we have z basically written here. And if we have this, then we can represent it as the following. You can see this is the normal, this is mean, etc. But this is less than, and you need to find it. So it's simple. To find less than 500, then it will be pz, then less than that. It will be like negative value here, so it will be 1 minus phi of the same value, and here it is. And then we have just found it in the table, and we have it. So what we have this, and this is 1.84% less than the half of liter of oil. And that's all. And if you want to know the next things, so let us see what we can do with the next thing. Like find the probability that exactly one of three randomly selected tins contains less than half of liter of oil. So here we need to understand that we have to find one. So here one out of three randomly selected. So here we have this one, but we need to have the combinations. We choose one, and you multiply by this and that, so you know that, and you finally get the answer. So this is how it goes. Yeah, and here we need to solve those tasks now. So let us solve some of them in the other exercises.